Good morning, Ria.
Good morning, sir.
So we'll get started. Okay.
Yes, sir. Sir, you're muted. We can't hear you.
Wrongly posted as 10th math, but it's physics. Anyways, should get started. Okay. So today we are going to actually we didn't discuss this chapter, no? Current electricity. Okay. So we'll discuss this chapter. So do you want me to go with the theory or shall I directly start the problems?
We can start the problem, sir.
So just to give a quick outline, I'll just run through the theory. I'm not going in depth. So first term that we need to know is what is electric current. So electric current is defined as the rate of flow of charges. It is defined as Q divided by T. And another point to be noted is 1 coulomb of charge is constituted by 6 into 10 power 18 electrons. Means 6 into 10 power 18 electrons together constitute to 1 coulomb of charge. Right. Similarly, there is another topic called as electric potential and potential difference. So how do you define this electric potential as? It is defined as the amount of work done per unit charge. So what is going to be the SI unit of it? It is going to be volt, and 1 volt is defined as 1 joule per 1 coulomb. Right. Similarly, so when you talk about the circuit diagram, you know what are all the parts that are associated. One is an electric cell, a battery, or a combination of cell, plug key, right, which is open, and a plug key which is closed. You have a wire joint, wires crossing without joining. Then you have electric bulb, resistor, variable resistance, ammeter, and voltmeter. So I hope you know all these parts. These are all the ones which are used in the circuit diagram. So what does Ohm's law speak about? Anybody?
So it states that at constant temperature, the potential difference across the conductor is directly proportional to the current flowing through it.
And so V is directly proportional to I at constant.
Constant temperature.
So V will be equal to I into R. This is the mathematical expression for Ohm's law, and this is what we use to solve most of the problems. So one note I would like to give here is when you apply Ohm's law. So to apply Ohm's law, circuit should have one battery or cell, whatever you call it, one battery or cell, and only one resistor, right? Only then you can apply Ohm's law. So write down the statement. What is the meaning of this? I'll explain when we solve problems. Done. Next. So factors on which the resistance of a conductor depends. So resistance is observed to be directly proportional to the directly proportional to the length of the conductor and inversely proportional to the area of the conductor. When you combine both, R will be proportional to L by A, which is also implying R is equal to rho into L divided by A, where rho is called as the resistivity, right? Next. So when you talk about the resistance of system of resistors, there are two types of connections which we can follow. One is series and the second is parallel connection. So in series, what happens? Current through all the resistors is going to be the same. Whereas in parallel, what will happen? The potential difference across each resistor will be the same, right? So what is going to be the equivalent resistance in series? Rs will be equal to R1 plus
R1
R2.
plus R2 plus R3.
So 1 by Rp will be equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? And you have another concept called as heating effect of electric current. So when current is passing through a resistive device for a longer duration, then what will happen is heat will get generated, which is given by the expression I square R into T or V square by R into T. Or it can also be written as V into I into T, where V stands for the potential difference, I for the current, and T for the time through which the current is flowing through that particular device, right? So practical applications and all you can go through in the textbook. So the last concept that we have is what is electric power? Electric power is defined as the product of potential difference and the current. And the power is also given as I square R or V square divided by R, right? So what is the unit of power? Unit of power is watt, and 1 watt is defined as 1 volt into 1 ampere, or it is also written as V into A. And the last one is commercial unit of electrical energy. What is the commercial unit of electrical energy? It is 1 kilowatt.
Kilowatt hour.
1 kilo is 1000. Watt hour is going to be 3600. So 1 hour is going to be 3600 second, right? So when you multiply, you will get 3.6 into 10 power 6 watt second, but watt into second is also called as joule. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. Okay. So these are all the concepts. So having said this, we'll get started with the problems. Answer. Which of the following is most likely temperature of the filament of an electric bulb when it is working on a normal 220 volt supply line? See, actually, this not a question that you can answer without knowing the background. Answer is 2500 degrees Celsius. Have that in your mind. Okay. Means if a bulb is supplied with a 220 volt, what is the approximate temperature that it is going to generate? It is going to be somewhere around 2500 degrees Celsius.
How do we calculate it?
Sorry?
How do we calculate it? Because we only have
No need to calculate. No need. This is a theoretical question. That is what I told you. You need not calculate. Just know the answer. That's it. No. The resistance of a certain copper wire is 1 ohm and the resistance of a similar nichrome wire will be about. This also you cannot do it unless you know the resistivity. So this also we will leave. Tell me this.
If one lamp fails, the other
C, sir.
The other will remain lit, sir.
Yes,
C.
because that is the advantage with parallel connection. So resistivity of a conductor does not depend on its length or thickness because
It depends
is-
on the nature of
the nature of material.
answer is C, 5C. Right. So at a given time, a house is supplied with 100 ampere and 220 volt. How many 75 watt, 75 watt bulb, which is operated at 220 volt, could be switched on in the house at the same time if they are all connected in parallel? So let's say you have one resistor here, 2, 3, 4, like this, it keeps on going, right? So when you keep connecting the resistors like this, let's say we need to connect n resistors so that it is connected to a battery source of 220 volt and a current of how much value is supplied? 100 ampere is supplied. Okay. Now, how many such bulbs can be connected is what the question is.
So is it 293 bulbs?
Correct. V is equal to IR. So V will be equal to how much? 100 is equal to V is not 100, V is 220. Tell me how to do. How did you get to 93?
Yes, sir. So basically, I I calculated the power of the whole thing, that is V into I, which is 100 into 220, and I divided it by 75, sir. And it's actually a decimal number, but I took it as 293.
Okay. So 220 should be equal to, or what I can do is, power will be equal to V into I. So how much is the value of power that you got?
So I just took it as 220 into 100, sir.
Yes. So 220 into 100, you need not multiply it. Am I right? Then what did you do to this?
Also, I divided it by the power of one bulb, which is 75 watts.
220 into 100 divided by 75. This will go 4 times. This will go 3 times. It will be approximately 73 point something.
It will be 293.333. It will go recurring, sir.
The answer will be 293. So that's the answer. Next. Two conducting wires of the same material. So same material means same resistivity. And equal lengths and equal diameters. Equal length is L is the same. Equal diameters means area is the same. Are first connected in series and then connected in parallel in a circuit across the potential difference. The ratio of the heat produced in series to the parallel combination would be. Answer. So they're asking the ratio of the heat generated in the series to the heat generated in the parallel, which will be IS square RS into T divided by IP square into RP into T. So T and T are lost. So how do you calculate the value of IS and IP? Assuming they both are connected to the same potential source, then how will you write the value of IS? IS will be equal to VS divided by RS. So VS divided by, can I write it as 2R? Because both the resistors are connected of the same value and they are connected in series. Accepted. So VS, I'll take it as V. Is there any doubt in this?
No, sir.
No. Then what about IP? VP divided by RP. So it will be V divided by, how many resistors are connected in parallel?
R by 2.
So it will be 2V by R. Take all the values and substitute it here. So V square by 4R square into 2R divided by 4V square by R square into R by 2. So this and this will get cancelled. R and R are gone. R square and R square are gone. V square and V square are gone. So what are you left out with? It goes 2 times. 1 by 4 is the answer. Is there an option? Yes. So 1 by 4 is the required answer. Okay, next. What is the minimum resistance which can be made using 5 resistors, each of 1 by 5 ohm?
1/25.
So minimum resistance is possible when you connect them in
Parallel.
parallel. Maximum is possible when you connect them in series. So 1/25 will be the answer. So if two resistors of 25 ohm and 15 ohm are joined together in series and placed parallel with the 40 ohm resistor, the effective resistance of the combination would be. So 25 and 15 are connected in series, and this is connected in parallel with the 40 ohm resistor. So what is going to, so this is going to be 40, and here it is 40. So it is going to be
20 ohms.
20. So 40 and 40 are in parallel. 20 will be the answer. When area of cross section of a conductor is doubled, the resistance becomes
Half.
Half.
Think and tell me. Sure. Huh?
Yes, sir. Half.
Yes, sir.
only,
Half, sir.
Yes. So listen, if there is a question where they ask a wire is stretched or compressed, okay, at that point answer will not be half, it will be 1/4. But if the same wire's resistance is doubled, I mean area of cross section is doubled, means you are not changing the length. Only then you can say R is inversely proportional to A. Are you able to understand the difference between these two terms?
Yes,
When a wire
sir.
is there, when you extend the wire, area of cross section will decrease, but length will increase. Whereas here, what did they say? They didn't speak anything about length. So it gets doubled. Answer will be half. The ammeter is used to measure the current flowing in the circuit. It is always connected in series with the resistor because
It has low resistance.
low or no?
Low resistance.
B. So had they mentioned it as ideal ammeter, then what will you say?
No resistance.
Had they mentioned it as ideal, this is the answer. If they only mention it as ammeter, then it is low. So 100 joules.
An ideal ammeter and ammeter.
Sorry, ma. Ideal is perfect, which is 100% perfect, which does not exist actually. But theoretically, if somebody uses the word ideal, it means that it has no resistance. So 100 joules of heat is produced per second in 4 ohm resistor. What is the potential difference across the resistor? So H is equal to V square divided by R into T. So H is 100 is equal to V square divided by R is going to be 4 into
20 volt.
Oh, they didn't give the time.
So per second, sir. So into 1.
100 joule per second. Yeah, then it is fine. So 4, which implies V square is equal to 400 and V will be 20 volt. So heater coil is rated 100 watt and 220 volt. It is cut into two identical parts. Both parts are connected together in parallel to the same source of 200 volt. Calculate the energy liberated per second in the new combination. Answer.
So is it 400 joules?
Correct. So first, what are we supposed to do? You need to calculate the resistance of the wire. How much is going to be the resistance of the heater coil? You can use the formula V square by P. So V square is
400 grams.
4 into 10 power 4 divided by 10 power 2. So it will be 400 ohm. Now what is happening? It is cut into two identical parts. When a longer wire is cut into two equal parts, what is going to be the resistance of each? It will be 200 and 200. Now, this 200 and the other 200 are connected in parallel. So what will be the equivalent value? It will be 100 ohm. Am I right? Is it clear till this step?
Yes, sir.
It is going to be 100 ohm. Now, what will be the energy released per second in it? So calculate V square by R into T. So how much is it going to be? 4 into
400
10 power 4 by 10 power 2 into 1. So it will be 400. I hope it is clear.
Yes, sir.
Okay. So the values of I flowing in a given resistor for corresponding values of potential difference across the resistor is given as below. So plot the graph between V and I and calculate the resistance. So where should I take V and where should I take I? If I take V on the
Y-axis is V and
Y-axis
I-axis
is
is
V and X-axis.
so this is 0, 0, 0.5 and 1.6. 1, 3.4, approximately double. Then 2, 6.7. So how is it going to be? Actually, it is supposed to fall on a straight line like this. Right? So how do you calculate the resistance of this? The resistance will be equal to delta V divided by delta I. So potential difference between any 2 points. So 3.4 minus 1.6 divided by 1 minus 0.5. So 3.5 minus 0.6 is going to be 1.8 divided by half. Answer will be 3.6. Right. So if the current I through a resistor is increased by 100%, then find the increase in power dissipated. So what is increase or change means? So change means, fractional change means final minus initial by initial by initial. This is a fractional value. If they ask percentage change, it is fractional change multiplied with 100. Fractional change multiplied with 100. I hope you understood what is the meaning. Fractional change means.
Yes, sir.
So I dash will be equal to how much? See, if initial current is I, it is increased by 100% means what will be the final current that it, so the value is increased by I. Okay. So I dash will be equal to 2I. So what is the value of P dash? P dash will be equal to 4I square R and P will be equal to I square R. Take these values and substitute it. 1 minute.
So is it 300%?
That should be the answer. 1 minute. My device is not writing. So 4 minus 1 divided by 1. Answer should be 300. See, my device is not writing properly. So 300% is the answer. I hope everybody understood. Okay. See, what is Ohm's law? How can it be verified? You can do an experiment in. So how can it be verified means you need to write the experimental description for it. So what is Ohm's law? You have already told. At constant temperature, the Potential difference is observed to be directly proportional to the current. So let's do this. 1 minute. Let me check. So 3 students XYZ are while performing the experiment to study the dependence of current on potential difference across the resistor. Connect the ammeter, battery, key, and resistor in series in the following orders.
So is it
So basically, they are doing Ohm's law experiment. Answer.
so is it Y?
Why? What is the answer?
So because battery should be connected to ammeter and then key and then resistance and then again to the battery. There's a circuit.
That's how the circuit is designed for Ohm's law. So answer is Y. So these are all experimental based questions. You can expect them. Okay, though these things will not be available in your textbook, you can expect them. Do this. Calculate the cost of seeing 2 movies on color TV daily for month of September. Given the wattage of color TV is 60 watt, duration of each movie is 2 hours 30 minutes, and 1 kilowatt hour cost ₹4. Do this.
So is it 36 rupees for the first one?
Which one? 58. No? Correct. So how many hours are they watching in the month of September?
150 hours.
5 into 30, it is going to be 150 hours. Okay. Power is 60 watt. Then what is going to be the energy? 60
Power
into,
into time.
so 60 into 150, which is going to be 9,000 joule, or 9,000 watt hour or 9 kilowatt hour. So it's basically 9 units. So 9 multiplied with cost of each unit is going to be the cost, that is going to be 36 rupees. Correct. What about this? An electric kettle rated at 220 volt and 2.2 kilowatt hour works for 3 hours. Calculate the energy consumed and the current drawn. So energy consumed, multiply 2.2 with 3. So energy consumed will be how much?
6.6.
6.6 kilowatt hour. Okay, that is easy. Calculate the current drawn. How will you calculate the current drawn?
So P is equal to VI.
Okay, power is equal to V into I. What is the power?
2200 watts.
2200 is equal to V is 220 into I. How many times does it come? So I will be equal
10.
to 10. So it draws a current of 10 ampere, right? Next. Do this. Answer.
So total current is 7.04 ampere.
Correct.
And resistance is 31.25 ohms.
Correct.
So I calculated I separately for each resistor.
So it's 31.2.
What is the current through it means? They're asking through the combination.
Yes, sir. I calculated I separately and then added it.
That's right. So I'm calculating equivalent. Somebody told 31.25. That is right. So 31.25 ohm, correct. So you need to calculate the current individually. How did we calculate it? I is equal to V square. Sorry, V by R. Sorry, power I wrote for power. I is equal to V by R. So how much is it going to be? It's going to be
2.2 amps.
2.2 amp. So I1 is 2.2. I2 is?
Should be 4.4.
4.4. I3 is?
0.44.
0.44.
Yes.
So when you add all these things, what you will get? 2.2, 4.4, 0.4.
7.0.
7.04, sir.
Okay, 7.04 ampere is the total current that is drawn by the combination. Okay. Now, which uses more energy? See, this I converted to kilowatt hour, I'll get 0.25. Into time is 1 hour. So it is going to be 0.25 kilowatt hour. Here, 0.12.
So
Sorry,
1.2, sir. 1.2, sir.
1.2 into 10 minutes is going to be 1/3 of an hour. 1 by 6th of an hour.
1 by 6, sir.
1 by 6. It is going to be 0.2 kilowatt hour. So which one consumes more? Obviously, the TV which is running for 1 hour. So this one you need not do actually. Because mass, specific heat and all will come. 1 minute. You need not do this. Leave it. Do this. 5 resistors are connected in a circuit as shown in the figure. Find the ammeter reading when the circuit is closed. Means they're asking what is the current drawn by the circuit.
So I have a doubt.
Mm-hmm.
Okay, so R1 and R2 are in series, and R3, R4 and R5 are in series. And then
No. R1 and R2 are in series. That combination is in parallel to R3.
yes,
After
sir. So
you solve-
R3 are no, so R3, R4, and R5 they are in another series.
They're in the series pattern. So whenever you start solving, you need to first identify the battery, start it exactly from the opposite end. Now what you did is right. So R1 and R2 in series, it is going to be 6. So the 6 and 3 are in parallel. So how much will it be? 6 into 3 divided by 6 plus 3, which is going to be 2.
2.
Now you will have 0.5, 2 and 0.5, which is connected across a 3-volt battery.
So current is 1.
So I will be equal to 1 ampere. That's it. I hope you could understand. No? It's very simple,
sir.
but don't do it in this kind of shortcut in your exam. You need to write the detailed step. You need to mention whatever you told me. R1 and R2 are in series. So equivalent combination is 6. After that 6, you have to draw another circuit like this. You have to draw another circuit in such a way that this is 0.5, this is 0.5, this is 3, and this is going to be 6. Again, you have to mention that these two are in parallel and then proceed. Got it?
Yes, sir.
So why does the electric current start flowing in a circuit the moment the circuit is closed? Why is it happening? See, when something is moving, right? If something has to move, somebody has to do work. So when the circuit is closed, who is doing the work on the charges inside the wire? It is the battery. You're able to understand what I'm trying to say? So the work done by that battery is what is going to get, what is going to put the charges in motion. So answer is going to be, when the circuit is closed, the potential difference is developed, which drives the charges inside the wire. Okay. Second, when do we say that the potential difference across a current, across a conductor in a circuit is 1 volt?
When 1
joule of work
is
is
done to
done
move
in
1
carrying 1 coulomb of charge.
Very good. Calculate the potential difference in the two terminals of battery. If 12 joules of work is done in transferring 2 coulombs of charge. NCERT in-text question.
6 volts.
6, sir. 6 volts, sir.
Well, V will be equal to W divided by Q. So it is going to be 6 volt. That's it. A letter A consists of uniform wire of resistance 1 ohm per centimeter. Okay. The side of the letter are each 20 centimeter long, and cross section and cross piece in the middle is 10 centimeter long with an apex angle of 60 degree. Find the resistance of the letter between the ends of the legs, between the points B and C. See, though they have given it theoretically, they have drawn the diagram. So you need not break your head in finding out what are the resistances. Right. So this is 10, this is 10, 10, 10, and 10. How are we supposed to start solving the problem? These two 10s are in
Series.
Series.
So how much will be the answer?
20.
20.
This 20 and 10 are in
30.
parallel. So 20 into 10 divided by 20 plus 10. That is 20 divided by 3. Okay, that will get replaced with 20 by 3. So 20 by 3, this 10 and this 10 are in
Series.
Series.
series. So it will be 20 plus 20 by 3. How much will be the answer? 80 by 3. That's it. So the equivalent resistance is going to be 80 divided by 3. Okay, we are done with this. So is there any other concept from this chapter which is bothering you? I think you guys are doing good already. Is there anything else which you want me to explain?
No, sir.
Okay. And one more thing is this human eye and colorful world is there, right? Which was supposed to be the
Yes,
topic
sir.
today. I think it is full of theory, right?
Yes,
Is,
sir.
is there anything
It's
that
only
from that you want?
lens.
Which one?
No, sir. I was saying is only the diopter. There's nothing else.
Only the diopter part. So, is there anything that you want me to explain from them? The diopter part also, we already saw it in that light chapter itself. I explained it.
Yes, sir.
Yes, sir.
So, other theory, only suggestion I would give is you need to be thorough with your NCERT.
Okay, sir.
Okay, you just see whenever any question is being asked, only thing is even if you have extra knowledge about it, right? Strictly for sake of marks purpose, I'm saying you strictly stick to the content that is there in NCERT, nothing outside that. You need not write anything extra or anything less. Exactly whatever is there, if you write it, that's more than sufficient. So that's the only suggestion from my side. So I'm expecting that chapter to be a self-study chapter. Okay. If you have any doubts on that, you can anytime reach out. Okay. So having said this, I would like to know any other problem from this chapter that you couldn't solve, you tried. Because tomorrow you have test, no? Any problem that you couldn't solve? Nothing?
So can you tell about the total power when connected in series and when connected in parallel, like total power consumption?
See, total power consumption, did you learn in foundation?
Yeah, sir.
It's not there. You don't have it for your 10th standard. It's only there for 12th. So if I tell you, you'll get confused. Yeah.
Okay, sir.
Yeah. Apart from that, see, whatever I showed you here is, you would have seen the theory part, right? The topics that were there. That is the exact replica of your NCERT. Only those topics are there.
Okay, sir.
Okay. So if that's the case, shall we wind up? Just give me a minute. Just give me a minute. So many of you are there. 2, 3, 4. 4 of you are there. Okay. So chemistry sir is having some meeting, it seems. Okay. He's not available at between 11:30 to 12:30 to handle. Anyway, I checked the schedule also. Metals and non-metals is not a part of your test for tomorrow. You have only carbon and its compounds, right? So sir told he can handle it in the evening, but we are yet to reach out to him. Once we get an update from him, we'll let you know. If it is not happening today, it will be rescheduled. Don't worry. Is that point clear? I'll drop a message in the group also, but since you people are there, I thought I'll tell you in person.
Okay, sir.
Okay?
Okay, sir.
You can start preparing for tomorrow's test. Okay? Don't have any backlogs. Try to score center. You would have seen what are the mistakes you made in the previous test, no? Improve your marks. Okay?
Okay, sir.
Okay, sir.
Wind up, guys. I'll see you all. Yeah.
Okay, sir.
Thank you, sir.
Thank you, sir.
Sir.